Have you ever watched one of those sci-fi movies where the main character enters a whole new dimension?
Yeah. Man, I wonder if humanity can also enter these new dimensions. Is there ever a way for our 3D brains to understand past the third dimension?
Well, we have the tools to do so. Let me explain. Understanding past the third dimension will require more advanced forms of mathematics, one of these being topology. You may have heard of topology with the seven-bridge problem, the donut coffee mug analogy, or the Mobius strip, but at its core, topology is a study of the properties of spaces that never change under any continuous deformation.
What does that mean?
Let's use the famous donut coffee mug example. To a topologist, a person who studies topology, the donut and the coffee mug are essentially the same thing. They both have one hole, and either one could be stretched or deformed to become the other. The only things that change the topological properties of either object would be closing holes, opening holes, tearing, gluing, or passing through itself. Since the donut and the coffee mug are topologically the same, we say that they are homeomorphic. Okay, but that might be a bit confusing. Let's dive into visual geometric patterns. Take the polyhedra, a solid figure with multiple plane faces. If we take a deeper look at the numbers and subtract the edges from the vertices, then add the faces, we always get the same number, 2. This number is the Euler characteristic of the polyhedron, and this number is the same for all polyhedron shapes without a hole, even a polyhedron or shape with an infinite or zero amount of flat surfaces.
What?
Okay, let's take a look at this shape. Since we know it's a polyhedron, we know it has an Euler characteristic of 2. Now what if we divide the flat surfaces and increase the complexity? You'll see that its Euler characteristic is still 2. If we divide and approach infinity, the number of flat surfaces becomes 0, yet the Euler characteristic is still 2. You might recognize this shape. We call it the sphere.
So you see, even though a sphere and a cube, a donut and a coffee mug look different to us in our dimension, topology looks past that. And that's why if we want to understand past our own dimension and unlock mathematical and quantum secrets, topology will be a key factor and tool that we can use.